Okay, Professor Kim, I think we will start now.
Okay, that sounds wonderful. Yeah.
Hi, everyone. Welcome to the last NLP seminar of this semester. We're so happy that everyone is here. If you would like to stay informed about future NLP events, I'm going to post a link on the chat, and you can fill out the Google form to get an email about our future events like the seminar. Today, we are very lucky to have with us Dr. Juho Kim from KAIST. He's also the director of KAIST Interaction Lab and is currently spending a sabbatical year at Ringle, which is a startup building an online language tutoring platform. His research on HCI and human AI interaction focuses on building interactive intelligent systems with the goal of improving how people learn and take action online. Very excited. Thank you so much for being here. And yeah, let's get started.
Okay, yeah, thank you so much for the kind introduction and also inviting me to speak at this seminar series. I'm very excited, and today's talk is a rather special talk for me because I will be giving a keynote at the NeurIPS conference in a couple of weeks, and as a sort of an HCI person doing HCI research, I feel like I want to kind of advocate the type of research that I'm doing and sort of bring people's attention to why interaction of how people are using AI technologies really matters. So with that kind of agenda, I'm going to use today as sort of an opportunity to sort of share my upcoming NeurIPS talk and almost in a practice talk kind of manner. And I would love to get people's thoughts on whether what I'm saying actually makes sense and is compelling enough, and or if I'm misrepresenting any of the communities. I feel like if I don't do a good job of it, I will embarrass both the HCI community and also somewhat offend the ML community, and definitely I don't want to do that. So yeah, with that in mind, I will share my screen and get started. Yeah, and please feel free to ask any questions in chat, and I'll try to address them as I go. Great. And my understanding is that we have an hour-long session for the talk and maybe another half an hour or so for Q&A. So I think my talk is going to be about 15 minutes long, plus and minus. So please keep that in mind. Okay, so yeah, I'll formally get started. Today I want to talk about this idea of interaction-centric AI. It's not necessarily a new idea or a new paradigm or anything. It's something that as an HCI researcher and the HCI community, we've been doing for a long time. And it's more of a call to action for why we should think harder about interaction as we build AI technologies, and the need for collaboration between the two communities. So let's say, as a machine learning researcher, let's say you and your team built this amazing diffusion model technology to generate images from text input. And I just copied and pasted this from the diffusion model paper. And honestly, I don't understand many of the technical terms here. So that's basically the characteristics of the technology that you have as a machine learning researcher. But then what the user of these technologies might want is something like this, right? So the user would probably want to create an image of a character that's eating ramen. So this is actually a real example from one of the YouTube streamers in Korea, where he had this 2-hour-long journey of creating the image that he wants using a diffusion model. And what is the interaction then? So for the user to be able to use this kind of AI technology, they need to have an interaction channel. And for these kinds of models, it's this text input box where the prompt could be entered. So here's a quick walkthrough of what this streamer had to do for 2 hours until he was able to get at the image that he actually liked. So he started with something very simple. So at the top, you see the prompt he had, masterpiece, best quality. I guess these are norms in the prompt design. It started with eating ramen, fairly simple. And this was the image that was returned. And it's kind of got the idea, but for many reasons, it's not really ideal. For example, the chopsticks are really oddly placed and so on. So he kept experimenting through trial and error, because that was basically the only interaction modality that was supported by the system, right? You enter some input, get the visual output, and you revise your prompt based on what you see. And he relied on some of the folk theories, like the beliefs of how these systems actually work, that might or might not be grounded in the actual technical knowledge, right? So in the middle, he says something like, "Oh, I heard somewhere that adding a full sentence can make a difference." So he then is trying to describe in a full sentence. So he goes on as she is eating ramen. It's not slightly improved, but still in many places, it's not really ideal. So he keeps going on. As you can see, the prompt is getting longer and the descriptions are getting more specific. And it seems like the AI doesn't really get how many chopsticks there should be and how chopsticks should be properly used. So he keeps on adding more descriptions, more specific instructions of what he wants. And after many of these tries, his prompt gets long. Still, there are some things here and there that are off. And here's the version he sort of liked. And, in many places, it's looking quite all right, except that he didn't really like how the chopsticks were held, and the color of the noodle didn't really match with what was in the bowl. And same here. And another interesting aspect was that viewers were suggesting alternative prompts that he could use. And he decided to accept some of them, discarded, ignored some of the others. And it was interesting how, as sort of a group, people were trying to do sense making of how this AI actually works. And the system also has this capability of presenting multiple outputs that are slightly different. So he relied on this feature sometimes. But interestingly, it was really hard for him to predict what kind of outputs he would be getting. So on the right, as you can see, he was praying, like after hitting enter, he was like, "Oh, this time, please, please." Right, so it kind of signals how unpredictable the results are and makes us question whether if this is really the intuitive and ideal user interface for playing around with diffusion models. And after 2 hours of hard work and 5 long lines of prompt, he finally was able to get at this particular image, and he was really happy with what he has. So is this a good user interface? Part of it is really good, right? It's quite intuitive. You can use natural language to express what you want, and you can be descriptive, and the system can kind of understand it. Not perfect. And you get the output in the visual image, which makes it easy for you to kind of understand and match with your intent. And some level of variations and using something as seeds are supported, which makes it which enables you to kind of use some of the existing outputs to prompt the next ones. But then for many reasons, this is also a pretty bad user interface. First of all, he had to rely only on trial and error. The system did not really give a good predictability, good level of predictability, and he had to pray a couple times. And there was lack of specific feedback, and it was hard for him to understand the impact of using a particular word or a phrase, and he only had to guess. And finally, it was difficult to communicate his intent. He had to fiddle around with different ways to express his intent. And if you compare this against communicating with a human illustrator, it would have been much, much easier. As a back and forth, you can, chat with this person to indicate what you want. Whereas here, it was hard for him to gauge the sense of how well the AI actually understands his intent. So this brings us to the classical HCI concepts, like the gulf of execution and gulf of evaluation, introduced by Donald Norman in 1986 in his book. So gulf of execution means that as the user is using a system, they want to understand how the system works. And often people want to have control and agency. They want to make sure that they can manipulate how the system works with a clear understanding of how the system works and what to predict, what to expect. And on the in the other direction, there's the gulf of evaluation, which is about what the current state of the system is. As the system is producing outputs and presenting to the user wants to understand what they are seeing. They want to interpret. They might want some explanation. And there is a gulf because oftentimes these are not perfectly aligned and matched, and many of the systems fail to do that. And that's why it's really hard to design a usable and useful user interface. So at the center of this gulf, there's the mental model. The mental model is this conceptual model of how the user thinks the system works. And oftentimes the mental model would be incorrect, in that for the user, it's really hard to understand how exactly the system works. And with more complex and deeper models in AI, I think having a clear and accurate mental model is actually getting harder and harder. So let's come back to sort of the machine learning researcher's perspective. Oftentimes, the goal of machine learning research would be to work on technical advances in AI model and the architecture, so that it performs better, results in better accuracy, maybe uses less computation power and storage, things like that. But we need to broaden this perspective. My concrete suggestion is that we need to zoom out and expand how we look at this ecosystem. And one way to do that is to look at this user, of how they are using the system by trying to understand and improve the mental model that they have about the system. And we can also expand on the y-axis of time, of not just thinking about this narrowly scoped interaction at the moment of the user using the system. We can ask these contextual questions before the user comes in and uses the system. And as a machine learning researcher, we can ask these questions before you choose which research question to tackle, because it really matters at the end who uses these AI results and why, and when and where and how are they going to use it. And by trying to answer these questions, maybe the type of problem you choose to tackle might change, because you think maybe this is more important than some of the other problems that there are. And during the interaction, there would be these issues of how to present the AI result in a meaningful way so that the user can understand them, how to visualize them, how to design the interface, how to make things more interpretable and transparent. And also, these interactions are not just a one-time thing, right? Once the user starts to use the system and gets some value out of it, they're going to come back and they will keep using. And the user is not a static entity, right? They evolve, their needs evolve, their understanding of the system evolves, and what they want evolve. They learn, they misuse, they abuse, they tinker with systems, they learn about the systems as they go on. So we need to be thinking harder about the longer term engagement of how users are using these systems, and how the user adapts to the system, and how AI adapts to the user. So all of these questions are something that we need to keep in mind as we are designing and developing AI technologies, because without those, having a real world impact on real world users would be near impossible. So my goal today in this talk is to kind of convince you that, I mean, those of you who are, HCI researchers, I guess I'm just repeating what you, have been saying all along in your research. But those of you who are relatively new to the idea of HCI, human AI interaction, I want to convey that human AI interaction really matters. And it's not just about some non-AI people's work to make better interactions and try to understand interactions. I believe having more interaction-centric approach to designing and developing AI technologies can really advance machine learning research as well. And I'll try to illustrate it through some of the examples. So as a human-computer interaction researcher, I mostly do system building and understanding how people use these systems. So in my research, I often try to envision new ways people can interact with AI technologies. I build them into a user interface that real users can actually use. And through usability studies and evaluations, I try to validate whether these expected support is actually provided and people are happy with what they see and get, and people are able to actually achieve better outcomes in their tasks and so on. And in the remainder of the talk, I want to share some of the hard-earned lessons by working on these systems. And I tried to organize them into 4 distinct challenges. Challenges in designing for human AI interaction that I think are really important for us to consider. So the first challenge is to bridge the accuracy gap. So what do I mean by this? So as in the introduction, it was briefly mentioned that I'm currently spending my sabbatical year at this startup called Ringle. So it's a language tutoring platform where they are trying to match an English tutor with an English learner so that they can have this video-based tutoring session online. And the work that I'm doing there is that because these sessions are recorded, we get sort of a word-by-word interaction between the tutor and the student. And using this data, we turn them into text scripts and then run a bunch of different analysis and NLP techniques based on the language learning literature to automatically generate feedback for the students about their language proficiency in terms of things like complexity, accuracy, and fluency. So that's all good. But I'm not trying to get into the details of what that involves, but rather I want to drive our attention to the error in the automated speech recognition AI that is a central piece in this technology, its service that I'm designing. So automated speech recognition is really important in this context because it turns the spoken dialogue between the tutor and student into a text format, which then can be used by a different set of diagnostic engines that we have to provide high quality feedback to learners. But of course, these ASR engines are not perfect, and they are often measured in terms of word error rate, a standard metric of their accuracy. And there is a disparity between the tutor and the student. Can anyone take a guess as to how different the accuracy might be between the two groups? Any guesses, like numbers?
For higher errors from students' voice, I guess.
Sorry, what was that?
Higher errors from the students' piece.
Yeah, higher error rate on the student side, yes. So the answer is based on hundreds of sessions that we currently have, it's 8 versus 23, right? And obviously, student speech doesn't get that much accurate transcripts when we run ASR and AI. And there's even a bigger gap when we look at the best tutor and the worst student in terms of the accuracy of this ASR. 6 versus 36. That's a pretty big gap. And so this is the accuracy gap that I'm referring to, is that, and ironically, students are the ones that really need an accurate ASR in order for us to, help them by giving better feedback and so on. But those who need the technology are disproportionately getting a more negative impact of using AI, because the accuracy is much worse than with the best tutors. And in other contexts, researchers have been showing similar patterns. Right, on the left, what you see is researchers who have studied in emergency departments in a hospital. They have these discharge statements. But for people who are not, native English speakers, hospitals often just run machine translation like Google Translate to explain these discharge statements to patients and their families. But then, of course, translation is not perfect in many ways, and they were studying in how many of these statements the meaning may not be retained or may be distorted. And there is a disparity between different languages. In Spanish, the error rate was about 6%, but whereas in Farsi or Armenian, it goes all the way up to 45% of these statements where the meaning is not really retained. And I know that in the NLP community, people are paying attention to supporting low resource languages. So I think, again, this shows how accuracy gap could be an issue. And on the right is the famous example of the gender shades, where the gender identification classifier shows a disparity between different race and gender profiles, and darker females versus lighter male get a pretty large accuracy gap of about 20 to 30% of gap. And I think what's notable here is that if we think of these research advances, technological advances, in terms of floor and ceiling, we're facing this accuracy gap. So in the case of ASR, on the floor, we have students who get like 36% of their spoken language not properly transcribed. On the ceiling, we have the native speaking tutor with only 6% accuracy. But I feel like a lot of our focus, like engineering focus, research focus, is paid to actually raise the ceiling, making the best case better. And this, I would say, is a model-centric approach, where we get incentivized by beating the state-of-the-art technology and models, and beating the benchmarks, and making the best cases better. It's also somewhat fancier, you get more attention. But the downside of that is that the accuracy gap actually widens as a result. And I would argue that by carefully understanding what kind of disparities there are and what kind of interactions people would like to have with AI systems, we might decide that maybe raising the floor is the more important problem to tackle. And as a result, we might be able to narrow this accuracy gap. And it's not just about accuracy, right? We start with the accuracy gap, but this in turn leads to the gap in terms of experience, benefit, and value that people get. So I think it's not just about building models with higher or lower accuracy in different settings, but we have to understand that this inherently leads to people's overall quality of service that they're getting, and we need to think harder about bridging this accuracy gap. So there was a first challenge, and I want to move on to the second challenge of incentivizing users to work with AI. So when we think about putting AI technology out there, of course we need to ensure that people would want to use these AI technologies and continue to use it. And one of the most common interaction patterns, unfortunately, is that people stop using AI at all or abandoning it. And there are many reasons for it. In most cases, it's because they're not really gaining any value from it, right? If you do some I don't know, like automated correction of your text, it turns out that you might have to spend more time actually fixing the AI error than the time it takes for you to just use the automated one. You might not want to use it anymore. And other times people misuse and abuse AI, which can cause harm to other users. And we've seen many examples of such failure. So it is important to think about incentivizing people to work with AI. And it should involve understanding people's needs and providing concrete value to them, which inherently involves understanding their interaction with the system. So I want to illustrate this point with a particular research system that we've worked on in the past. So this is in the online education setting. And the problem that we noticed was that there are lots of problems, like learning problems out there. So let's say you want to learn some probability, and I'm sure we can find lots of problems that we can solve so that we can learn about these concepts. But then in learning, it's also important to get high quality explanations as some form of feedback, so that you can understand why something is the right answer or wrong answer, and you can correct your misconceptions. But unfortunately, not many quality explanations exist because they are costly to generate, and there are limited resources to generate good explanations. So we thought maybe we can involve learners to do this. So this is a system that we built. So it's a very simple sort of learning interface where the system presents the user, the learner, with some question, and they solve the problem and submit an answer. And the system presents an explanation to the user. So what gets shown, I will get back to this in a bit. And then they are asked to rate how helpful the explanation that they're seeing was. So from 1 to 10, they rate the quality of the explanation that they are getting. And then interestingly, the system presents them a way to add their own explanation, which is called the self-explanation, which is a highly effective technique in terms of learning. Because you get to use your own conceptual ideas of how something works by trying to externalizing them in text. So this is a fairly simple application, but at the back end, what happens is that we formulate this in a multi-armed bandit problem, meaning that each of these arms is an explanation that's submitted by each of the learners coming into the system. And because we can expect many people to come in and use the system can basically have a large number of possible explanations. And of course, the problem is, how do we pick the good explanations to show to upcoming people? So for this, we use Thompson sampling and treat this as a classic sort of reinforcement learning formulation, where we need to navigate the exploration trade-off. Exploitation in terms of presenting people with the best effective explanations that the system thinks, and exploration in terms of getting more information about these explanations, which are the ratings that people give about each of the explanations. And we use Thompson sampling to generate this dynamic policy for choosing which explanation to show to the next learner coming into the system. And because new learners may be coming into the system anytime and adding their own explanations, we need to hit a balance of, we need to give a fair chance to new explanations coming into the system, cannot just rely on previously highly rated explanations. So that's where this dynamic policy part comes in. So to just illustrate how the system works, when a new explanation comes in, a new arm is added as sort of a byproduct of the human learning activity. And then the rating data comes in, and the system updates this policy with the new explanation and the rating information. And the policy keeps getting updated. And for the new learner, the system looks at this policy for the next learner. And with this probability distribution, it picks an explanation to show to the next learner. So in this system, we were able to see some positive results. So our system is called Axis, and we measured whether people are learning their probability problems better when using the system. So we compared against two different conditions of having no explanations at all. So this is sort of the baseline. And the instructor condition is when people are presented with the instructor-generated explanation. And what we found through this pre and post-test comparison is that we measured how many points people gained in the post-test condition after using these interfaces. So after getting no explanation, people still scored 3%, 3 points higher, probably because they had a chance to rethink their previously incorrect answer and things like that, but it's pretty minimal. But in the instructor and Axis case, it was both significantly better than the no explanation case with the 9% and 12% increase. And there were even cases where Axis was performing better than the instructor, which illustrates that sometimes learners were even able to provide higher quality explanations than the instructor provided explanations, which kind of shows that this learner-generated explanations or learner-sourced explanations can be valuable. So in what sense is this incentivizing people to interact with AI? If we were to build a more model-centric system, we can think about automating the generation of explanations. And there are great NLP models out there that can probably do a good job at it. But then we thought, okay, that's all good, but then we don't want to just provide better explanations to people. We want to give people a chance to self-explain. And even with the perfect explanation generation capabilities of AI, it cannot really, replace people's self-explanation effort, because that's how you inherently learn. So that's why through our sort of interaction-centric approach, we decided to design this co-learning system where the users get individual benefits, like pedagogical benefits, by interacting with the system in natural ways. And at the same time, the system collects useful information for it to continue to get higher quality explanations. And I believe this is a more sustainable mechanism because even with better and better AI technologies, it can actually come in and compete with the existing explanations, and the system can eventually select the better performing ones. And also because AI cannot directly replace people's work. Maybe in terms of quality of explanations, it can, but it cannot replace the self-explanation activity that people do, which can help people learn further. So this kind of co-learning system is an example of how systems could be designed in a way to incentivize people by providing individual benefits of using the system, while the users can provide valuable input to AI at the same time. Now moving on to the third challenge.
Juho,
I think it's really...
We have a question.
Yeah, I just saw the question. Yeah. So Zemyong had a question: how do you ensure the correctness of the explanations? So in this particular experiment, we don't. So our expectation is that it will be filtered out through people's rating efforts. And of course, some of the learners will be presented with this poor explanation or incorrect explanation, but over time, these will be filtered out because they will be rated lower. Yeah, but then, of course, there is an interesting question of, is this ethically okay? And with the dynamic policy, it minimizes the chance of poorly or incorrectly written explanations to be shown to more people. but it is true that they are still shown to some fraction of learners. So maybe an improved version of the system could involve more the verification stage that could be done in the beginning to at least make sure that the explanation indeed makes sense. Yeah, that's for the question. Okay. Yeah, so I'll move on to the third challenge of considering social dynamics. So what I mean by social dynamics here is that AI is not only applied in a single user context. So in the earlier diagram that I showed to you, you might remember that there was a single user and the single AI interacting with each other. But in real life, it's much more complex. In that creator YouTube example earlier, many of the viewers engaged in suggesting different prompts that could be used, and in other cases people might be seeing some results of the AI and share them with other people. So these social dynamics in these cases actually play a very important role in how people use these AI systems. And again, I want to illustrate this point through one of the systems that we built in a couple of years ago. So it's a system called Solution Chat. So here we wanted to help people lower the burden of moderating a discussion online. So in chat-based discussion, I'm sure many of you have been involved in chat-based discussions to make group-level decisions and things like that. It's very hard for these sessions to be moderated for many reasons. So as a moderator, they have to keep track of all the discussions happening and making sure that everyone is contributing, and they have to keep track of time and make sure all the agenda items are covered. So it is a lot of cognitive effort on the moderator side to handle. So we thought maybe we could build a system where we could try to lower this moderation burden. But the way we decided to do that is not by designing a completely automated moderator AI, but rather we decided to build a system that presents real-time moderation messages so that the human moderator can choose to accept or ignore the moderation messages. And I'm sure you can guess why we chose that route by now. So this is a system, and on the left, it shows this agenda panel, which has nothing to do with AI. It's just a way for people to be able to keep track of the discussion that's happening and be aware of the agenda that they have as a team. And important decisions and ideas could be added or removed from this panel too. On the right, we have this message recommendations. So these blue blocks are the real-time recommendations that get displayed by the system. And these are messages like, I wonder what this person thinks. Can you tell us your opinion when this person has not been participating for a certain amount of time? Or are there any more ideas? Should we vote now? Or any evidence for what you just said? So for generating these messages, we rely on literature, on discussion-based learning, as well as some simple NLP to kind of infer people's intent in these discussion messages to pick the most appropriate, contextually appropriate message to show at a given time. So it's just a matter of just picking a message that seems appropriate on the moderator side. Very simple. And you can imagine it's very similar to how something like a smart reply in Gmail, for instance, works. So with this system, we ran this controlled study with about 55 people in 12 groups, where we compared 3 different conditions of the baseline, which only had the chat without the message recommendation and the panel on the left, and the version with the agenda panel, but with no recommendation, and finally, the solution chat version with everything. And what we found was that people were actively selecting the system-generated recommendations. On average, in each session, these moderators picked about 10.5 messages that they accepted. And these are illustrated by the blue bar at the bottom. So you can see that there's a huge spike due to these automatically recommended accepted messages that people have accepted. And we also analyze a type of messages, the prompts that these moderators use. And we were seeing that more managerial prompts related to managing the current chat discussion were more common, more frequent when the message recommendation was available. But again, I want to draw our attention to not how well the system worked, but rather the social dynamics and the human AI interaction that we observed, some of which were not really expected. There were some interesting cases of how people were using these message recommendations. First of all, some people were using AI as a proxy. So one of the people said, I didn't want to directly ask the person to stop talking. And that's why this person chose to use the message recommendation to kind of do it on their behalf. And they would often add, oh, this is the AI recommendation that I used. And it kind of softens the possible social pressure in saying something more direct to other people. And in other cases, people use AI as a reference. So in our system, it was a very simple AI. It didn't really adapt to people's stylistic preferences and how they would, form their messages. So it was just more of a, canned response. And that's why some of the people said, I found no fun in the recommendation messages because all the messages look the same. So in these cases, people found a workaround. What they did was they saw a recommendation, they actually liked it, but chose to rewrite in their own words. Or other times they would accept it and then add some notes underneath to kind of add their own flavor. And finally, sometimes AI actually caused some social burden on the people using AI. So what happened in this excerpt is that one of the people said, I'm doubtful about the credibility of AI as part of the discussion. And this message recommendation that was accepted by the moderator says, thanks for your opinion. Another person says, I also think negatively, and thanks for your opinion. And thanks for sharing a good opinion. So the moderator just keeps selecting these messages, but then decides to apologize, like, sorry for my unnatural words as I'm using AI recommendations. So in this case, you could see that AI might have caused the social burden on the moderator's side. They were, selecting these messages, but then at some point they realized that it might not be appropriate, and they chose to acknowledge that and sometimes even apologize. So in this system, if we were to take a more model-centric approach, we would have designed an automated discussion moderation system, like a fully automated agent that runs the session all by itself, which might have been fancier. But in the interaction-centric approach, we decided to go with the AI-assisted moderation for various reasons. First of all, we realized that people actually want to have more agency and control in the moderation that is happening. And people wanted to display their own style in communication and moderation, as I mentioned earlier. And finally, moderation is not just about saying appropriate messages in a timely fashion. It does involve more broader and other creative tasks. So people definitely wanted to be in charge. So that's why we decided to use AI in a more assistive manner rather than a way that replaces the human moderator. Okay, now moving on to the final challenge. This is about supporting sustainable engagement. And this has to do with how it's not going to be just one-time usage of AI applications. And in a good way, we want people to continue to use AI systems, but then we need to understand what it takes for people to sustain their engagement with the system and how dynamically it might actually change. And again, I want to use my own experience, some of it successful, some of it actually not so successful, to illustrate the point. So the problem we tackled in this particular system was that novices of web design find it difficult to make changes on the website. That's quite obvious. But why people would want to do that, in certain cases, maybe the website that you're visiting has really terrible color that hurts your eyes, or maybe some of the menu items are not really visible, maybe the button is too small. You might want to emphasize some things to improve readability. So we thought there would be certain needs that even novices have about changing the website that they are seeing. But then without the knowledge in HTML, CSS, and web design, it's really hard for people to make these changes. So we imagined it'd be great to have a system that people can say out loud what they want. For example, like, tone down this text, and then the system would try to automatically recommend style changes that might be matching with the intent that they have. So here's a quick demo of how this system works.
Make this larger.
So the user said, make this larger, and the system is showing all these design suggestions that might have to do with making something larger.
Emphasize this part.
The user says, emphasize this part, which is somewhat vague, and the system tries to interpret this intent and trying to show different design elements that might be related to emphasizing the text. So to build the system, we relied on a combination of NLP and computer vision techniques. Again, I'm not spending time on the technical details here, but in terms of NLP, we used a large language model to kind of map the person's intent with the style attributes in CSS. In computer vision, we crawled millions of web design components all over the web to kind of decide what an appropriate suggestion of the particular design aspect might be. So after having this system, we were really excited. We ran some lab study to see if people can actually perform design tasks better when they were using our system, Stylet. So in this study, we compared Stylet against an existing sort of the standard way of making changes on the web, which is the Chrome developer tools. So by putting people into these two different groups, we wanted to compare their time, performance, and other perceptual measures. And we gave people two types of tasks. The first task was to turn this before image into an after image. So it's basically trying to understand what changes need to be made and actually make those changes. In the second task, we gave a more open-ended task by giving them this blank slate, and they were free to kind of make any changes that they want. Debarati had a question. How do you deal with prompt ambiguity? So tone down this text could be referring to the style of the text rather than the text style. Right. Yeah, so there could be ambiguity in people's intent. So for this, we did not really do any special treatment of this particular ambiguity problem. We mostly just relied on the matches that were given by the large language model, which could be one of the limitations of the system at the moment. Yeah. So in the our first research question was to see if people can do the task easily and successfully and fast. And quite expectedly, we were able to see that 80% of the Stylet users completed the task versus only 35% of the Chrome developer condition users. And also people were able to do things much faster. So success story so far. We also looked at the kinds of changes that people made, like web design changes people made, we found that in both cases, a similar number of changes were made, but in the stylet condition, people explored more diverse options, which I think is probably due to the fact that stylet presents, diverse alternatives and recommends these non-obvious options as well, so that people can explore and actually try out. But the most surprising and somewhat unexpected result was in this third research question, when we looked at people's self-confidence in their ability to design. So we had two tasks, right? So we asked people's self-confidence each time after each task. Initially, people's self-confidence increased in both conditions, which is good. Like, people were able to complete some design tasks. They felt more confident about their abilities. They felt like they were learning something. But interestingly, in the stylet condition, people's self-confidence actually went down after they completed task 2. Whereas in the developer tools condition, it kept increasing. So in the developer tools condition, people felt more rewarded. So this is my first time handling CSS, but I did this. So they were kind of happy that they accomplished something. But in stylet, it seems like people were feeling somewhat restricted. People were saying, I expected more surprising changes like glittering. And also, they wanted to have more control and wanted to make fine-grained changes in design. But they were left with only the natural language prompt, which often didn't give them the level of precision that they wanted. And this is going all the way back to the earlier prompt engineering case in the very beginning, where the user sometimes struggled to form good natural language queries to truly express their intent. So in sort of the temporal scale, this shows us that initially people were excited about how web design changes were easily made by their natural language query. But as they were gaining some knowledge of how CSS works and how web design works, they wanted to have more control and directly manipulate the designs by themselves, but the system still only gave them the natural language interaction, which was somewhat limited for them. So we can imagine maybe the version 2 of the system could take a more adaptive approach by giving people more freedom and control as they are getting more experience and expertise in the design, which I think could have been a nice design to explore. But broadly speaking, we are relying more and more on these AI technologies to do various kinds of tasks, like grammar checking or producing text, as can be seen here in terms of Grammarly and GPT-3. But then an interesting question is, what is the effect of using these systems in the longer term, right? Of course, the result that we produce will be higher because grammar will be better and the text would be more complete and more creative perhaps. But then what does it mean in terms of our own skill level or the control that we have? Can we say that people actually learn better, or they are better in grammar and writing as they use these systems for a longer period of time? Or is it that we just over-rely on these technologies? So I think we need to have a more systematic understanding of these longer-term effects of using these systems. So again, to kind of reflect on this particular challenge. So if we were to take a more model-centric approach, we would have tried to build a system that automatically just optimizes the design fixes. But then we chose to take a more sort of a recommendation-based approach for various reasons, because it might give people a chance to customize, it might give people a chance to explore and tinker, and by giving people recommendations and letting them explore, people were able to actually learn the skills that they previously did not have. So these were the 4 challenges, and now I want to wrap up by sharing some call to action items. So through today's talk, I tried to make a case that human AI interaction happens in a very complex and multifaceted, dynamic manner that's really hard to anticipate all in the beginning. And at the same time, without a careful consideration of these interactions, people are not going to use these systems, or AI might actually cause harm because interaction has not been clearly considered. So for those of you who are doing machine learning research in the audience, I think it's not just the point is not just that you should learn about HCI or do more interaction style work. I think more concrete action items would be to rethink some of the ways that we do work. And this rethinking should happen not only in the ML community, but also nearby communities like HCI communities, design communities, and so on. First of all, I think we need to rethink metrics. The questions we should be asking are, do the metrics for evaluation really capture the diverse user values and expectations? And often, the benchmark-oriented culture and more sort of accuracy-driven culture may promote competitive advancements of these metrics. But then sometimes we need to step back and ask if these metrics are actually the right metrics to tackle. And how do we know what the right metrics to tackle are? One way to do that is by observing how people actually use them, or what would really matter for people to get the value out of their interaction. And second point is we might need to rethink the design process. And some of the examples today, as well as most of how AI-powered applications are designed, we see that it often starts with the technology, with the model, right? So let's say, here's this cool diffusion model. What can we do with it? What are some interesting startup ideas? What are some applications we can build around it? And interaction comes kind of post hoc as sort of an icing on the cake. But maybe it should be the other way around. Maybe by starting with users, understanding their needs and challenges, we can try to use interaction as sort of the guiding principles behind the design and research process, and also deciding what problems to even tackle and what the role of the AI model should even be. And finally, we need to rethink collaboration. And all of these nice sounding ideas can only be made possible if different communities actually talk to each other. So my call to action is that the different communities need to interact more and talking to each other, thinking about better metrics, better design process, so that these amazing advancements in AI can make a truly lasting impact on real users. So that's all I have, and this is just a summary of what I said today. And thank you so much, and I'd be happy to take any questions. Thank you.
Thank you so much, Joe.
Thank you, Professor Kim. If anybody has any questions, they can raise their hand, post it on the chat, or just unmute themselves.
I have a quick question. So first of all, thank you very much for the talk. I especially really like the slides showing raising the ceiling of the performance gap. That's really meaningful, I think. So I mean, I'm not really familiar with HCI studies, but some of the studies I've seen, I thought that they're kind of rely on the goodwill nature of human beings, whereas in the wild, the humans are pretty selfish. So for example, going back to your English learner example, so the students providing explanation example, I think fewer students might have participated if there were no additional points to be earned or forced to be participated. And if you take a more drastic example, people seem to abuse the system for their own gains. For example, in Korea, we had this big political scandal with people abusing the rating systems of the news comments, so that the comments with a certain political agenda gets to be shown at the top. So what do you think about letting so what do you think about this kind of sort of like a side effects of the human system interaction, and what could be the measures for that?
Yeah, that's a fantastic question. And yeah, as you noted, in sort of the lab studies, these naturally negative and harmful behaviors don't really show up because, you know, people are there because they volunteer to participate in a study and they are getting paid, and the researcher is watching right next to you. So yeah, you'll basically get very clean data, if you will. But of course, we know that in the when these are, you know, deployed to real life users in a live setting, we get all sorts of these unexpected cases of, you know, abusing and misusing and harassment and things like that. And the field of, you know, HCI has been you know, very deeply studying these phenomena, in trying to understand why people do that and how the design of these platforms and systems actually afford people to exhibit more of these behaviors and not. So of course there are kind of human nature kind of things, but at the same time there are things that the technology and the design of the systems that can be done to mitigate the harm caused by these actions. And that's why I think we need to think harder about people's like motivation, incentive structure, and if like design principles and guidelines that could be set, so that these goodwill behaviors are promoted and people who are making positive contributions get more rewards, whereas those who are, you know, misusing or contributing bad quality contents, for example, are demotivated to do so. So that's a sort of the social computing challenge that many of the HCI researchers have been studying, and I think many of these could be translated into the design principles for building these systems.
Okay, thank you.
You.
I have a question. So at the beginning of the talk, you mentioned that whether your talk fits well to AI and machine learning, NLP folks. Yes, it does. And I think I learned a lot, and the talk was very like thought-provoking and like eye-opening. So it works well.
Oh,
But going back to my question. So I have a yeah, one question is, you mentioned about the credibility of these AI systems, and if the AI system makes some mistakes or unsatisfactory outputs, users are not satisfied and don't come back, right? So in what level of performance do people expect when people are using this kind of AI system? And more precisely, let's decompose the performance into maybe precision and recall. Maybe this companies are taking more conservative approach, right? So just focus on the precision, but do not care about the coverage, but make the prediction to be very accurate. So maybe people can sort of like some sort of like a trust or credits coming out, but don't care much. And then maybe they can take care of like coverage or recall parts later on, right? So how do you relate the user's credits or user's satisfaction with respect to the AI model's performance, and in terms of precision and recall, like how do you expect? Yeah.
Yeah, that's a lovely question that requires a lot of thought into answering. And I feel like there are, you know, two families of thoughts in evaluation, right? In the machine learning community, it is more about sort of the generalization of the error in new situations through measures like precision, recall, and accuracy measures. Whereas in the HCI world, we would often try to understand user satisfaction and with their task performance and the perceptual measures and so on. And often, in an ideal manner, the two would highly correlate, or even there's a causality between the two, in that the better model indeed leads to higher satisfaction. But unfortunately, many of the studies have been showing that it's not as simple as that. And accuracy is often one of the factors that defines the holistic user satisfaction. And for example, one really interesting study, I forgot the actual authors of it, was showing that they were comparing high accuracy model versus slightly lower accuracy model, but then gave explanations and ways for people to leave feedback on the system. And the results were that getting explanations in a lower performing models was not helpful, because the model was not good enough. But then why does it even try to explain itself? It's I'm not happy with that. But people were more satisfied when they had a chance to leave feedback on the system. So it has to do with sort of the control that they have, and the sense of having a chance to express their satisfaction to the system. Seems to have a positive impact on the user satisfaction. So yeah, coming back to your question, I think accuracy is only part of the equation. But even the accuracy itself, I think, depending on the context, as you noted, maybe precision is more important in certain contexts, whereas in other contexts, recall is more important. But I think making that decision should be based on, again, like observing users, understanding their needs and expectations.
I see. Cool. Thank you. My second question is about the interfaces. So you explain about this recommendation-based interface for the stylet projects. You also have other language-based interface for this discussion mitigation and etc. Right? So maybe there are different ways of interacting with AI system, right? Using tooltips or using the language as an interface, use the recommendation, and then let people to choose, or etc. So among these, do you see the clear pros and cons of using language as an interface to interact with the AI systems? And if you have some experience, what could you share with us? Like, what's the pros and cons?
Yeah, that's again a great question, and especially given that we're in the NLP seminar. So yeah, natural language interfaces have been studied for decades in the HCI community, and so some of the systems that I've introduced today are also falling into that category. And yeah, when we are building these interactive systems, often one of the most important decisions that we have to make is to decide on the interaction modality. Like, would it be natural language? Will it involve like clicking and drawing, or should we go multimodal by combining like clicking and speaking? Or would it be just relying on the recommendations that the system gives? And again, I think it has to do with what the user task is, what their constraints and preferences might be, and what they expect the system to do. And often for natural language interfaces, I found them useful when people don't really have enough of the domain knowledge. So mostly for like novices who are new to the domain with limited expertise, they might not have the right vocabulary to kind of describe what they actually want, or if they're given a set of menu items with a bunch of jargon, they're not going to be able to really understand them, and they would then resort to trial and error. So that's why natural language, I think, is going to be effective in those cases, because people can still express what they want in plain terms, in terms that they're familiar with, and hopefully the system would be able to bridge the gap between the two to kind of map that to the more complex system functions there are. So I think that's where natural language would be preferred, I think. And even within natural language, we did some we had some interesting design decision in one of the other systems that I did not present today. We were trying to build this natural language based video navigation system. So it'd be something like, let's say you're watching this, tutorial video on, like Photoshop filter. Then you would be able to like speak what you want by saying, go to where this like cell phone was shown in the scene, or go to where this tool was used. So we were hoping that by serving these kinds of commands, people would just speak what they want in the video, and the system would show where things would pop up. But one thing we learned is that people don't want to talk to the video player. So our sort of ideal usage scenario was that people would have a conversation with the video player to kind of find information they want. But probably because in a video watching setting, just watching the video is much more important, and that's where they want to spend their time on rather than actually talking with the video player. We saw that people mostly just resorted to listing the keywords that they want. So rather than saying, take me to where this is happening, they would just say cell phone or this filter. So we learned that maybe more like full sentence commands versus keyword based commands, not like, like fully natural language support is always better.
Then, like, just adding to that, do you think this prompting with the large language model or DALL-E stable diffusion, is it going to be like effective interface for creativity or productivity kinds of purpose?
Right. Yeah, I have mixed feelings about those, and I briefly mentioned this as well. And let me just go back to that slide. Yeah, seeing this gave me mixed feelings about prompt as a user interface, right? So I mean, this YouTuber spent 2 hours coming up with this final prompt, and it's somewhat cryptic. I mean, it is natural language based, but of course, it's not something you would naturally write, right? It's a mix of all these different attempts and what he thinks made a difference, and yeah, all these like tips here and there kind of plugged it in. So I feel like, I mean, do we think this is a natural way to interact with AI? Perhaps not. I mean, in many ways, it's somewhat cryptic, it's overly complex, it reflects many of the unpredictability that the user has about the system. But these prompt-based systems, I think, are still very powerful because, previously it was not even this level of support that was provided. Often, users had to control like complex parameters of the model that they have no idea what they are even about. Now we at least have a way for people to use natural language to kind of express what they want, and they can easily experiment with different versions, which significantly lowers the bar to participation and entry. And I think that is a huge accomplishment. And it also has to do with the nature of the model, right? Whether the model is able to use a natural language query to produce an image. And depending on the model architecture and how it works, that might not even be possible, right? So yeah, it also adds to the complexity of what interaction is actually able to be supported by the model. So there's the alignment issue as well. But then, like, moving on, I feel like this is the right direction. And having this natural language support is definitely worthwhile. But then I think there are many things that should be added on top of it. So for example, it's still mostly relying on trial and error. Like, people have to try, see something, doesn't work, go back to their query, but not knowing exactly what to fix in many cases, right? So the system could try to give better feedback in terms of what worked, what didn't work. Maybe it could even try to recommend some of the effective prompts that they could try out, or it could be made to so that things are more predictable. And we can also think about adding more interaction layers on top of this. So for example, like comparing different versions and branching out and sort of hypothesizing about a particular effect and, making a decision based on what the results are. So all of these more complex human interactions and efforts, I think, could be added on top of the basic architecture. And I think by adding these layers of support, I think these could evolve into a more usable interface.
I see. So in HCI, do you think there are some commonly used interaction principles to interact with this non-deterministic systems? I mean, traditionally AI systems were like a rule-based and outputting just one single outputs, labels, etc. But nowadays it's unpredictable and non-controllable and stochastic. And then, I mean, it gives some power of like creativity, of course, or generalization power, but it's not interpretable and controllable at all. So do you have, in HCI field, do you have any interaction principles of this kind of like non-deterministic interactions?
Yes and no. Yes, because that's what a lot of researchers try to do, is to kind of generalize these design principles and interaction design paradigms, or like frameworks and toolkits and APIs that we can use. So for example, in graphical user interfaces, things like having a window, the menu bar, icons, so these have been the inventions, right? These are not like given interface widgets. They have been invented by people who are designing user interfaces as a way to interact with more control and efficiency in the graphical setting. Beforehand, it was all about just text-based command line interface, right? But then with these like new advances in AI, there's a question of, can these existing interface components and the libraries that we have, do they actually stay relevant? And are they the right metaphors? Are they the right interfaces to use in the upcoming advances of AI? And I think the answer is partly yes and partly no, because while some of the interface techniques that we have can be applied to sort of align with the technical nature of these non-deterministic AI-based systems, but I think we need to think about more like a new generation of interaction mechanisms for these models, because they're so complex, because of their like at scale nature of things. I do personally believe that we need to come up with new ways of interacting with the systems, and that's a grand challenge for HCI, and not just HCI, and both HCI and AI communities, I think.
Okay, thank you so much.
Thank you.
I have a question. My question is related to the fourth challenge, which was related to sustainable engagement. Thank you for your motivating example about the image generation. So I'm curious about the trade-off between what happens if the user starts to engage with the system really well and he's able to use the tools really well, and then he uses it for bad. So like, for example, like in the case of the image generation system or any kind of news generation system, the more the better the user can interact with the system and they feel more engaged with it, they can also use it to create whatever they want, right? Which could be bad. So how do you implement a trade-off?
Yeah, it's a hard challenge, and you're definitely right in that as people are more used to the system, once they have a more accurate mental model of the system, and they will have more control in sort of getting the output they want in both positive and negative ways. And of course, I think it kind of goes back to one of the first questions about people's negative behaviors using these systems and so on, in that there's no like built-in ways to prevent these behaviors, right? I mean, there is all these capabilities that AI is giving, and people are free to kind of explore them. But when they are put into a service, when they're put into a community of people, when they're in a societal context, there should be boundaries, right? And these often involve not just like interaction or HCI level, but it should involve like regulations, legal implications, privacy, and like agreements in the service agreements and so on. So I think it's a much more complex problem to think about the overall sort of harmful behavior and these negative consequences of building these systems. And again, I feel like in many cases, these considerations often come too late, right? Driven by the technical advances, and then we think about whether there are these negative consequences, and then do something about it. And I think that kind of model is not really sustainable in my view, because it always will be leaving these holes where these other things are kind of having to catch up with the technical advances and slow to respond. And so I think this interaction-centric approach, I think can give us another sort of perspective to this kind of problem, in that we can try to imagine what these negative consequences might be even before the technology is actually built. If we can study people's interaction with the system even before the technology is fully functional, because we can kind of understand what it's like to be interacting with these kinds of technologies, and there are methods to kind of do that. For example, like Wizard of Oz technique is a well-known technique in HCI, where you kind of imagine that this imaginary technology is perfectly functioning, and see how people use these kinds of things. So these kinds of observations can help us better prepare for these negative consequences.
Thank you.
Thank you.
Are there any other questions?
Not exactly
yeah.
a question, but so one of the barriers for me to getting the users involved and creating the system is the technical difficulty itself. So like when we want to design an interactive system that involves users, the system, well, you need someone who is proficient in front end and back end and whatnot, right? So like, do you have any sort of guidelines or tips in that technical aspects of the designing systems?
Right. Yeah, in a lot of the work that I do, or my group does, we do a lot of the interface building kind of work, which involves a lot of like front-end implementation and coding and some level of design work. And yeah, and like realistically speaking, we cannot expect, let's say, a machine learning researcher to have all these skills so that they do like front-end prototyping while working on their machine learning research, and vice versa, right? As an HCI researcher, many of my students try to apply machine learning techniques, but they wouldn't definitely have the level of knowledge of like a machine learning researcher of these technical advances. So, so I think it again kind of goes back to my sort of call to action in terms of collaboration, in that both communities need to speak to each other and collaborate, so that we need to find ways where these AI techniques are more easily put into the usable interfaces by working on maybe the common frameworks and toolkits and guidelines. And these are useful because then even like non-design experts, non-HCI experts can sort of refer to them or use them to quickly prototype or build their inventions. And vice versa, right? And like AI technologies could be made more usable if they are easily deployable and like Hugging Face for example, does a very good job of that, for instance, even for non-AI people to quickly try things out and get a feel of how it's like. So I think these kinds of efforts need to happen more actively in both directions to foster more of these, bridging the gap between the two.
Yeah, thank you very much. That sounds really good.
Just one side
I actually had
Oh, sorry. Go ahead.
Sorry, can I ask like one question to the people here? I don't know exactly like what backgrounds everyone have, but so one sort of a thing that I was curious about, or one sort of potential concern that I had about this talk, was whether like people doing like machine learning and NLP research would feel like, okay, it's all good, but then it's not really something that I can do something about. Is this really like affecting how I should do my work, or what's the takeaway message? Because it might be that a lot of it seems like what HCI people are doing, and maybe you just do your thing and I'll do my thing, and interaction kind of sounds good, but then I don't know what I should do about it. And so I was wondering if people like felt like there were actually some actionable items from what I said today, or if there are things that you thought there could be. I would love to hear your thoughts.
Why don't you share your thoughts?
Yeah. Hi. So my background is NLP, but I'm really interested in learning more about HCI, so this talk was very useful to me. I'm specifically interested in exploring, at the end you talked about rethinking metrics. So in general, this talk was really exciting because the benchmark culture that we work in is, I think, a little bit limiting. So I'm excited to explore that aspect.
That's great. That's great. Yeah, and related to that, it's also true that we cannot expect like PhD students working on their NeurIPS deadline to suddenly think about 5 other metrics in addition to the ones that they're currently testing against. So I think it's a more sort of a community level discussion that needs to happen, and sort of setting the culture and changing the culture, and rethinking these benchmarks, and adding alternative benchmarks. And so yeah, I'm really excited about that sort of direction too.
Yeah, and I think that collaboration is really important, particularly with like projects that might need like human studies. That's something that a lot of us, I think, don't have a huge amount of experience with, but I think is important, particularly in terms of metrics.
Yeah, but please be careful, like our labs are supervised. So entire group of NLP group in here, we're working for like developing some human-centered NLP systems.
Right.
So maybe our opinions are a little biased, and maybe some other folks in AI or NLP, they don't care about the human side, and yeah, they only care like boosting up your whatever automatic metrics is, whatever. So yeah.
Right. Yeah. By the way, I love the work that you guys are doing, and definitely have been enjoying many of these human-centered approach you're taking in NLP. So
Appreciate it.
Yeah. And personally, I would love to talk more and find ways.
Yeah, one quick question. Well, as a HCI researcher, do you like the term human in the loop? I'm just curious.
Yeah, so there was this really fantastic conference last week at Stanford Human AI Institute, and there are videos online if people are interested, where it was mainly like HCI people talking about human AI interaction, and it provides a lot of the similar perspectives that I presented to you, and it was inspirational for me as well. And the title of the conference was Machine in the Loop, AI in the Loop. Not human in the loop, and they were kind of challenging the notion that by kind of referring this interaction as like human being in the loop, are we kind of, treating humans as kind of a like a object that kind of gets put in and out of the loop as we see fit, whereas maybe the better way to describe the relationship might be like AI in the loop, in that humans are doing their tasks in this flow, and AI can be put in and out depending on where they are needed and where the human wants them to do its thing and not. So I thought the perspective was quite eye-opening, and Jeff Bigham from CMU also talked about the loop itself, like what does the loop actually mean, and reflecting on the concept of a loop when we say human in the loop, machine in the loop. So yeah, so I personally think human in the loop still is a good term that captures many of what we hope to see more of. So I don't have like big trouble with it, but yeah, this whole mindset of maybe machine being in the loop and humans in charge, I think, is something that we need more of.
Yeah, I guess like this AI people and HCI people have a big gap by just looking at these terms, preferably use terms, and yeah, how we can treat human or machine in their research, and yeah. Anyway, thanks.
For me, the take home message was this performance gap diagram. So we see the speech to text paper saying that they achieved like 99.2% accuracy, but the test sets were actually created in a controlled environment, spoken by native English speakers and so on. So going back to the English learner example, I think we can sort of have a call for building more diverse test sets, including more speakers or test speakers from different backgrounds and so on. Yeah, so that was pretty meaningful, I think.
Mm-hmm. Thanks for sharing.
Yeah.
Yeah, for me, I really like the entire concept of the diversity in metrics. For example, in your system, which was about moderation, I liked how it enforced that we do need some creativity, and so maybe the metric in which the recommendation is more creative and not really catering to everybody else, that gets a boost, right? So you give more value to the system that's actually helping you more effectively, rather than the traditional metrics which help just cater to the usual audience. That helps in accessibility of the system, a lot of different things. So yeah, that's not things that we usually think about. So I'm very grateful. Thank you.
Mm-hmm. Thanks for sharing too. Yeah. Mm-hmm.
Oh, one maybe last question. Sorry, we're asking too many questions, but so from HCI perspective, you see the gap between AI research and HCI research, and users' real satisfaction is different from automatic matrices in an AI, right? But maybe from view from like outside academy and industry people may also have a different view. So do you think maybe the research findings from this HCI papers, which perform very restricted embodiments, and then less number of the sample size, and also less conditions, compared to the wild setting, like a realistic setting, do you see any people from industry or real company people think these findings are very limited or controlled and it's not practical? Or do you see any sort of like a gap between industry and HCI as well?
Oh, absolutely, all the time. And I think it's, frankly speaking, HCI suffers from this even more so than the AI community, partly because large-scale evaluation just is so much difficult. So for example, let's say you run a lab study with 20 people, that's quite possible. Can you run it with 20,000 people? Probably not, like in a university research lab, and, PhD students alone working on the system. Whereas in AI, it's relatively better, I would say, because like the benchmark sets could be tested on a relatively larger scale. But of course, there are resource constraints that I hear in terms of like GPU access and things like that, which can limit in their own ways. Yeah, so coming back to the question, of course, there are many concerns about the external validity of the findings coming from the lab study, many of which are coming from the great points that many of you have mentioned, like these people's natural behavior might not be really captured, or these negative behaviors, there's no really control that's been added to the system. So what we see is in like transferring these like paper findings to, let's say you want to apply these findings into a live platform with thousands and millions of users, these additional considerations are definitely needed, and often like additional design and engineering efforts are needed to ensure like like negative consequences are mitigated and things like that. But in research, often in evaluation, we cannot possibly control for all possible factors, right? So I feel like even if we're working on the same kind of user interface, the priority or the goal might be slightly different. In research, we try to sort of envision new interactions and make observations of what these particular interactions can achieve and not, and report on the unexpected interactions and so on. In industry, taking these lessons further, there would be a more sort of unique kind of considerations that should be made if it were to be applied to like millions of people. So there's definitely a gap, but I think still the research findings are relevant because there are still these messages that could be taken into account.
Oh, yeah, thank you.
Does anyone have any other questions? All right, if there are no further questions, then maybe we will wrap this talk up. Thank you so much, Professor Kim, for teaching us so much today.
Thank you a lot.
Luck on your talk.
Yeah, thank you so much again. Yeah.
Thank you so much.
Yeah.
And good luck on your NeurIPS talk.
Thanks.
Thank you. Thank you.
I'll catch up with you later. Yeah. See you. Bye.